So go to new schematic. So put a voltage source first, the supply voltage. Obviously there must be a resistor. The typical values of resistor will be something like 10 ohms. Ground must be there. In the controlled rectifying element SCR we'll place now. So let us type here SCR and you place it here. Control R for rotation, rotate and keep it here. Escape. Now let us do the wiring. Now let us put voltage source. So Indian supply voltage is 311 volts peak and 50 hertz. Right. Now let me move this a little bit so that things are clear. Now we need to add gate voltage here. So let us move this SCR, drag this SCR a little bit left side. Right. Now we need to put a pulse here. Escape. So let's do the wiring. All right. Now, so the total time period is 20 milliseconds. So let me trigger the thyristor after a delay of 2.5 milliseconds. So 2.5 corresponds to how many degrees? So 2.5 divided by 20 milliseconds into 360. So it corresponds to 45 degrees firing angle. So let us give a pulse. Pulse amplitude is 5 volts. Let us give after a delay of 45 degrees, which corresponds to 2.5 milliseconds. And the rise time, let us have very small number. Fall time, 1 nanometer small number. Right. How long this pulse should be on? So let me keep that also for 2.5 milliseconds. And period is same as that of the sine waveform, which is 20 milliseconds. This part is done. So let me move this. Right. Now the next important thing is now we need to of course we can start the simulation. Let me run. So let me run for 60 milliseconds. Now if you run, it says unknown sub-circuit called in, meaning this particular SCR is not defined. So we need to define this SCR. Let us take one model from ST Microelectronics. So I'm already having this file. I need to paste this file path. I need to paste the file path here. Go to spice directive. So you have to press .inc, include, control V for the path, and also we need to paste the file name as well, including extension. So including .lib extension, we need to paste it here. Right, that's done. Now let us open and see what are the various models that we are having there. For example, if you open that file, so various SCR models are available. TN3050H-12LY, TN5015H-60, whatever the model you want, you can choose. So let me take this first model. So TN, let me copy this name, Control C, going to my file. So now I need to name it, same name. All right. Now let us run the simulation. All right. Now let me first plot the sinusoidal waveform. This is a sine wave. This is perfect. Now we need to get the rectified output voltage perfectly coming. Right. Sometimes what happens is you may not get the simulation properly. The reason is this is the anode terminal. Now in the netlist order it is 1. Sometimes what happens is the netlist order might be different. So how do you compare the netlist order? So go back to this file. So check here, anode cathode gate. This is first, second, third. So the same order must be here. So anode was first, cathode is second, and let me check for gate. Obviously it is 3. Right. By mistake, if it is placed wrongly. So let us check that also. Let us check that condition as well. So now save this. Now let me run the same thing. Now you will not get the simulation. Sometimes if even though you would have done correctly, because you did not place the netlist order properly in the symbol, so there can be certain issues. Again, let me go back. The order is anode is 1, cathode it is 2, and gate is 3. Now again save this and run again. So this is how you will get. Well, now this is for a firing angle of 45 degrees. So that also you can see. So let me plot to a proper scale. So you can see, well, so let me take 2.5. That's also perfectly fine. Now if you happen to see, the firing started exactly at 2.5 milliseconds. Right. Suppose if I wanted to vary the firing angle to 90 degrees. So let me go here. So 90 degrees means it is 5 milliseconds. Right. Now let us do the simulation. So you will get exactly at 5 milliseconds. That's how it is. All right. This is about a simple R load simulation using SCR half wave rectifier. So the input waveform is a sinusoidal waveform. The output waveform is a rectified, meaning at the input you are having alternating current voltage waveform. At the output you are having direct current voltage waveform, the DC. AC is being converted to DC.